HCl is acting as the acid, Brustol-Lawrence acid, because it's donating the proton to the base, which is ammonia. Now I want to ask you this question. H2O, water, is it an acid, a base, or a salt? I know you could be tempted to say water is neutral. It's neither an acid or a base because you bathe with water and you drink water. However, we're going to see shortly, water can act as an acid. It can also act as a base, according to Brustol-Lawrence theory. How do I mean? Come with me. So if you look at H2O plus H2O, this H2O can ionize into H plus or H minus, and you have water here. This guy can donate the H plus to this guy. And what do you have left? You have H3O plus and you have OH minus. So by donating this proton to water, this water is acting as an acid. So I can as well say this is an acid, all right? And this is a base, which is a proton acceptor. Accepting proton from here, and then you have H3O plus. So water can have, it has the ability to act as an acid and a base by donating proton and accepting proton respectively. All right? Now, before we go to the next one, let's talk about the acid base, the conjugate acid base pair, conjugate pair. So there's something called conjugate pair. Conjugate pair. So in your exams, you could be asked, which of the following is a conjugate acid, a conjugate base, an acid or a base? So let me give you this illustration. HCl plus H2O to give H3O plus Cl minus. Alright? So for every acid, there is a conjugate base that completes the pair. And this is it. This is the pair, right? This is a pair. This is an acid. This is a conjugate base. This is a conjugate base. And then this is a base. This is a conjugate acid. Conjugate acid. So this is the pair. So let me talk about what is a conjugate acid. Remember, for every acid there's a conjugate base, not a conjugate acid. For every acid there's a conjugate acid. So an acid is a substance that gives out hydrogen ion or gives out proton. Now a conjugate base is that guy that is ready to accept a proton to become an acid. So this guy is ready to accept hydrogen, okay? And when it accepts the hydrogen, it becomes an acid. And you remember that bases are proton acceptor, all right? While acids are proton donor. So this guy is ready to accept proton, all right? Therefore, it's a conjugate base. Then this guy is ready to accept proton here. By the time he gets the proton or hydrogen from here, becomes H3O. So here, the base, which accepts the proton to become H3O plus, while the H3O plus is ready to lose a proton to become, and thereby acting as an acid. You remember an acid is a proton donor, so this guy has the potential to donate hydrogen, therefore it's an acid. So when you say conjugate base is a substance that has the potential to accept a proton or hydrogen and then become an acid. So having the potential to accept, that makes it a base. So that's a conjugate base, while conjugate acid has the potential to donate proton. Now let's go forward to the Lewis theory, which is the third theory, Lewis theory. So according to Lewis theory, an acid is an electron pair acceptor, while a base is an electron pair donor. So what does that mean? when we say electron pair acceptor, electron pair donor, what are we talking about? Let's have H plus reacting with ammonia. So to be able to capture this, I would like to write on this side H plus ammonia. Ammonia is a base. This is an acid. Alright, it's coming from an acid. You know, an acid we ionize to give hydrogen here, so this can be referred to as an acid. Now, by the time they react, so let's say what is actually happening here, how that this is an electron pair acceptor, electron pair donor. So looking at H plus, how many electrons can you say that this hydrogen has? Now, the difference between hydrogen and H plus is that this hydrogen has one electron. It has one electron. But H plus means it has 0 electron, because the one electron that it had as an elemental hydrogen, it has given it out. So when an element gives out or loses electron, its oxidation number increases. So this hydrogen has lost one electron, then its oxidation number has increased to +1. Therefore, the hydrogen, the electron it had initially, it has lost. So it's now having 0 electrons. So this guy has no electron, right? So here, hydrogen has no electron, but here, there is a pair of electrons that is left here. So let's see how that comes about. If you look at nitrogen, nitrogen is in group 5 of the periodic table. Nitrogen is number 7, atomic number 7. If you write the configuration is 2, 5, meaning it has 5 electrons in the outermost shell and needs 3 electrons to attain stability. So for it to attain stability, 3 hydrogen atoms will come around these 5 outermost electrons. So let's see how that works. So for nitrogen, nitrogen has 1, 2, 3, 4, 5. 5 electrons in the outermost shell. It has not attained stability. So hydrogen ion, okay, hydrogen will come. Hydrogen initially, the elemental hydrogen has only 1 electron. Alright? 1 electron needs to attain duplet electron in the outermost shell. That's 2. So each of the hydrogen will come with their own 1 electron. So let's say the electron for hydrogen is X. Another hydrogen comes here with 1 electron. Another hydrogen comes here with 1 electron. Then they share. So this kind of bond, chemical bonding, where both of them donate electron and they share equally, is called covalent bond. So there's a covalent bond between nitrogen and hydrogen atoms to give ammonia. That is why ammonia is a covalent compound, right? So here they share equally. And eventually nitrogen has 1, 2, 3, 4, 5, 6, 7, 8. So nitrogen has 8 electrons around it, and each of the hydrogen has 2 electrons around them. So these are shared pairs of electrons. So here we can say there are 3 shared pairs. 1, 2, 3 shared pairs, and there is 1 unshared pair. So 1 unshared pair. That unshared pair is also called the lone pair. Unshared or lone pair. Now, let's come back to how does an acid act as an acceptor of electron pair. So this acid will come to this guy. Remember, this is ammonia. It has 2 unshared pairs of electrons. So the hydrogen ion from the acid comes to this guy and says, please, I do not have any electron with me. Help me, I don't want to go childless. Can you help me? So it comes to and this guy says, oh, no problem, I have 2 electrons that I can share. So this guy is going to donate these 2 electrons, and both of them will share equally. And that's what you call coordinate covalent bond. Coordinate covalent bond is a bonding type wherein only one atom or element donates the electron pair to be shared by the 2. If you have not seen my video on chemical bonding, you can check up or check the description. You will see the link to the video. You can check it out. You see types of chemical bonding, and I've broken it down so that you can understand. Alright, so here hydrogen ion with no electron comes here and then it shares. Therefore, this base is acting as electron pair donor. So remember, according to Lewis theory, acid is an electron pair acceptor, while a base is an electron pair donor. So look at it. This guy is donating. So example of electron pair donor is ammonia, donating this pair of electron to this hydrogen, and then so this hydrogen could come from HCl. So HCl, okay, liberates H plus, and then that reaction occurs. And at the end, you can have ammonium chloride as the compound formed. Ammonium chloride is an example of a coordinate covalent compound formed as a result of this reaction. So this is Lewis theory, a base donating the electrons, electron pair, and then the acid accepting the electron pair. And so that summarizes the three theories. So let me give you, I promised at the beginning of the video I was going to give you a shortcut that you can use to remember the three theories. So the first thing you need to do is your Arrhenius theory is that popular theory that you quite often you were taught maybe in your secondary school in SS1 or thereabout, or SS2, which is an acid is a substance that ionizes in water to give hydrogen ion or hydrozonium ion as its only positive ion, while a base is a substance that ionizes in water to give hydroxyl ion or hydroxide ion as its only negative ion. That is the popular Arrhenius theory. Now for Bronsted-Lowry's theory, so the key is this: Bro-Pro. Bro-Pro means Bronsted-Lowry, the concept is about proton. So they defined in terms of protons. Alright? While Lewis theory, Lewis is electron. I see the electron Lewis. So Lewis defined in terms of the electron, Bronsted and Lowry's theory defined in terms of proton. And for this Bronsted and Lowry's theory, it says acid is what? Proton donor. Remember, you cannot give what you don't have. So an acid will always have hydrogen in itself. So every acid has hydrogen. If I want to mix an acid, according to Bronsted-Lowry's theory, is the presence of hydrogen. So you can't give what you don't have. So an acid is a proton giver or donor. A base is a proton acceptor. Now look at the twist. Look at the twist. A substance cannot be giving a proton and still giving electron at the same time. Remember, protons are positively charged, electrons are negatively charged. So you cannot be giving out positive and still be giving out negative at the same time. So when you give out positive, you accept negative. When you give out negative, you accept positive. So if an acid is a proton donor giving out positive, then it's going to be an acceptor of negative. Therefore, according to Lewis theory, we said Lewis is in terms of electron. Therefore, an acid is an electron pair acceptor. So for Lewis theory, acid is electron pair acceptor, while a base is what? Electron pair donor. Can you see that's the key? So Bronsted in terms of proton, Lewis theory in terms of electron. I want to believe that was very clear. So that is just the introduction to acids and bases. So I'm going to do a second video where I will talk about the types of acids, how they can be classified. You can classify acids into organic and inorganic acids, strong acid and weak acid in terms of their strength, and you can have concentrated and diluted acid. I'm going to explain all of that in the second video. And I will also talk about the physical properties of acids and bases. I will talk about their chemical properties as well. And I will go ahead to talk about salts. How can you identify salts? All right, what are the types of salt? I'll be talking about the types of salts. You know, types of salt, you have the normal salt, you have the acidic salt, the basic salt, you have complex salt, you have double salt. How can you identify them? I will do that in the next video. So make sure you check up for the next video. If you have not subscribed to our channel, go and subscribe right now. Also, I'll be doing a video on how to differentiate between a soluble salt and insoluble salt. What are the things you look out for that will make you know that this salt is soluble in water, can dissolve in water, or this cannot dissolve in water? I'll be doing that in the next video. I want you to subscribe to this channel, hit the notification bell so that when I drop the next video, you can be notified. Thank you for being a part of today's class, and see you in the next class. My name is Coach Paul. I am your tutor on your science subjects, physics, chemistry, biology, and mathematics. See you in the next class. Bye for now.